CLT, central limit theorem. So this is also known as the fundamental theorem of statistics, so it's kind of important. The whole point of this is because we want to know things about our population. We want to know average age. We want to know, I think I was just listening to something about how the average lifespan is actually not getting older, just kids are living longer. So it's kind of skewing the data. So we want to know about average. We want to know what the average is of the population. But we can't find the average of the population. We need to find the average of the sample and then use that sample to estimate the average of the population. They do this in boating all the time. You guys have probably seen that. So let's say I'm making some chili and I want to test how hot the chili is. So I take 1, 2, 3, 4, 5, 6 random samples. And what I'm going to do with those 6 random samples, so I took the sample, I got 102, 115, 107. These are all in degrees, 123, 116, and 114. So I took the sample. What I'm going to do is I'm going to find the mean, x bar. So this is my mean sample, 112.8 degrees. And my sample standard deviation is going to be, stat, calc, one variable stats, 7.4. So what I'm going to do is I'm going to build an interval. We call it a 95% confidence interval. 95% confidence. And we know that 95% of the data is going to be within 2 standard deviations of the mean. So what I'm going to do is I'm going to throw in my mean, which is 112.8. And the standard deviation. So since this curve here represents all possible x bars. So if I took 6 samples, sometimes I would get a mean of 112.8. Sometimes I'll get a higher mean. Sometimes I'll get a lower mean. But the mean of all of the samples should be pretty close to the population mean, which we call mu. So from here, what I'm going to do is I'm going to find the standard deviation, which is 7.4. And because this curve represents all possible x bars, I need to cut it. That's something that we learned on Thursday and Friday, is that as I take samples that are bigger and bigger and bigger, the shape looks a little bit more normal. In this case, it's going to be normal. And the standard deviation is going to shrink down by a factor of the square root of n. So divide by the square root of 6. 7.4 divided by the square root of 6. 3.02. We'll call it 3. So now what I need to do, I'm trying to build this 95% confidence interval, is I need to add 2 standard deviations to the right, and I need to subtract 2 standard deviations to the left. So if I take my standard deviation of the sample, which is 3, and I multiply by 2, I get 6. So if I take 112.8 and I add 2 standard deviations to 112.8, that's going to get me out here to 118.8. And if I subtract 6, that'll get me out to here. So this distance is 6, and this distance is 6. That'll get me to 106.8. So I'm going to say that I'm 95% confident that the true mean of this chili, the true bowl of chili, is between these 2 numbers. This is my standard deviation. This is my center. And then the new term is called your margin of error, ME. So your margin of error here is going to be this thing right here, 2 times the standard deviation. So if I get a mean, if I have a population mean of my chili that's 105, I'm going to be very surprised because 105 is over here. If I have a population mean of chili that's 130 over here somewhere, I'd be very surprised. Anything between 106 and 118.8, I'm not too surprised. That's going to happen by the natural variance. Let's do a couple examples. A survey was given to a random sample of residents of a town to determine whether they support a new plan to raise taxes in order to increase education spending. the percent of people who said they supported the plan to raise taxes was 49%. So that's going to be your, this is actually a proportion, but we're going to call it an X bar. So that's going to go in your middle, 49%. The margin of error of the survey is 3%. Write a confidence interval for the percent of the population that favored the plan. So the margin of error they gave us is 3% already. So the margin of error for us is going to be 2 times the standard deviation. So I don't care what the standard deviation is. They did all the hard work for me. They did all the mechanics for me. I don't care what the standard deviation is. All I need to do is I need to add 3 to 49 and subtract 3 from 49. So if I add 3 to 49, I'm at 52. And if I subtract 3 from 49, I'm at 46. So and again, let's see here. We're at a confidence interval. So this is going to be a 95% confidence interval. All the things that we're going to do in here is going to be a 95% confidence interval. Because 95% is an A. We're pretty confident at 95%. So I'm 95% that the true mean, or the true proportion of people that favor this tax hike is going to be between 46 and 52%. Let's do another one. A study of a local school tried to determine the mean number of text messages that each student sent per day. The study surveyed a random sample of 55 students in the high school and found, oh god, it's going to die soon, and found a mean of, so notice I'm underlining the important stuff, 196 messages, and a standard deviation of 61 messages. And a 95% confidence interval, find the margin of error, round to the nearest whole number. This is interesting because it says round everything to the nearest whole number. So this is a little different. You're going to do a little bit of delta math like this too. So in order to find the standard deviation here, and the mean was given to me, 196. So I'm going to put 196 in the middle. The standard deviation is going to be 61 text messages. But because I'm dealing with all of the different X bars, this curve represents all the different X bars, I need to divide by the square root of n, which is 55. So if I do 61 divided by the square root of 55, I get, and they want you to round to the nearest number, so I get 8.22. I'm going to round that to 8. So that's my standard deviation. Now what I need to do to construct my confidence interval, my 95% confidence interval, is I need to add 2 standard deviations to the mean and subtract 2 standard deviations to the mean. So I'm going to take 8 and I'm going to add 16 to the mean, and I'm going to subtract 16 to the mean. This number right here that you're adding and subtracting to get your high and your low, 112, and then 196 minus 16, 180. This is your confidence interval, so you're 95% confident. Ooh, that doesn't seem right. 212. You're 95% confident that the number of text messages each student, the mean of students send, is between 180 and 212. But the margin of error, the thing that you're looking for, the distance between your center and that fence post that makes things weird, is going to be 16. Got one more for you. A student at a local high school tried to determine the mean amount of money that each student has saved. The student surveyed a random sample of 79 students. Again, I would definitely recommend underlining the important stuff. And found that the mean savings is $2,400 with a standard deviation of $1,500. Determine the confidence interval, 95%. We're going to round everything to the nearest whole number again. So 2,400 is going to go in the middle. And then again, this curve represents all the possible means of students. So we're going to have to take the standard deviation, which is 1,500, and divide by the square root of n, which is 79. Which gives me rounding all values, so 168.7, so we're going to round that to 169. So now what I need to do is take that 169 and multiply by 2, because to construct my 95% confidence interval again, I have to go out 2 standard deviations from the mean left and out 2 standard deviations from the mean right. So the margin of error here is going to be 338. So finally, to find my confidence interval, I take 2,400 and I add to it 338, and that gives me 2,738. And then I take 2,400 minus 338, and that's going to give me 2,062. So I'm 95% confident that the true population mean is somewhere on this interval between 2,062 and 2,738. Anything outside of that interval, and I would be very, very surprised. So you got some delta math that you're going to be working on right now. Good job. Let me know if you have any questions. Peace.